right, ladies and gentlemen. So, um, as we move forward here, we are going to continue working with functions. We learned what one was, um, and how to find the domain and range. Ultimately, two things you need to remember as we move into this next assignment with functions. Number one, function and a relation for that matter is just a collection of points. The function is just a collection of points that has a specific rule, which is that when we plug in the number, we only get one thing back. So if I plug in 2 and I get back 3, if I plug in a 2 again, the only thing I should get back is a 3. That's a function. The other thing to remember is it's like a machine. I have a 2, I put it in, I get something back. Put in a 3, I get something different back. So that, or it could be the same thing, but as long as it's not a repeat of an x. But here we go with this. Here's the thing with functions. How do we name them and how do we use them? So here, and from the worksheet, what you're going to see is you're going to see 4 different functions. I'm going to take one and just talk about what this actually means. Okay, so now remember, it's just a collection of points put through a machine. This is read as f of x. F of x. If you hear me say f of x, that's how I'm reading that. Now, the f is just the name, just like your name might be Carter or Xavier or whatever. This is the name of the function, all right? Every one of these has a name, F, G, H, K. Okay. Each of them has a name. The F is just the name. The X is your input. This is what you're putting into the machine. So F is the name of the machine. X is what you are putting into the machine. Now, f of x as a whole, this is another way we write it. And this you have seen. Y equals 3, that's squeaking, 3x minus, there it is, 7. You've seen that before. F of x is the same thing as y, basically. All right, but here's the thing. Each of these has its own name. We don't want to just put y because then we can't tell them apart, maybe on a graph or whatever. So we give them a name. That's why we replace the y with f of x. All right, but here's your name, your input, and then this is the machine. This is the function. I'm going to just call it the machine. All right, this is the machine. This is where you're putting something in, and it's going to come back as something different. All right, so for example, let's take a look at this. It says k of 0. That's how you'd read that. So the k is the name. So you're going to look at your functions. This is f, this is g, this is h. There it is. That's k. That's the function we're going to use. Now, what do you notice about, let me pick a different color, this right here, k of x to here? What changed? The x turned into a 0. All right, that means that x, for this right here, x is 0. That's what you're plugging into the machine. We want to find the y that goes with x equals 0 when it runs through this function. Okay, so x is 0. That's what this means. That's what this means. Oops, right here, that x equals 0. Now we want to find the y. So let's plug in. Let's take -3. We're replacing the x with 0. And keep in mind, that's an absolute value. Those lines around the problem are absolute value. All right, so we have our function k. We plugged in a 0. Let's see what happens as we move forward. The next step, I'm going to write k of 0 every time, just so you can see something at the end. Absolute value stays, -3 times 0 is 0. The +5 stays. Absolute value, k of 0 then would be the absolute value of 5. Now, absolute value just makes whatever's on the inside positive. It's already positive, so k of 0 equals 5. That's your answer right there. So let me circle that, and let me tell you what this means. This is a point. It's the point, 0 is our x, 5 is our y. That's all that means. So we found our function that we wanted to use, k of x, and we plugged in a 0. We replaced every x with a 0, and what came out, we plugged it in, a 5. That is the 0.05. So the 0.05 is on, we graphed this function, 0.5 is going to be on. All right. So let's go to the next one. All right. It says g of negative 12. So our function that we are going to use is, here's f of x, here's g of x. That's the one we want. H of x and k of x, g is the one, that's the name. And what we're going to plug in for x is negative 12. That's what that means. So that means everywhere you see an x, you're going to put a negative 12. Keep in mind order of operations when you're doing this. All right, so for the last one, we wanted to do what was inside the absolute value and then take care of the absolute value. Here, we don't have anything like that. We have to multiply first. So we plug in that negative 12. Negative 12 times 1/2 would be negative 6. And then negative 6 plus 12 would be 6. That is your answer. And if you want to write it as a point, you certainly can. Negative 12, 6. That means negative 12 is your x, 6 is your y. That means the point negative 12, 6 is on. If we were to graph that, it's part of that function. It's one of the points that is within that function. And we'll talk about graphing afterward, but for right now, we're good to go. Now, this problem is a little bit different. It says solve for x if f of x equals negative 4. Now, keep in mind, remember from right here, f of x or g of x or whatever is the same thing as y. So what this is saying is, another way to write this is, it says solve for x if y equals negative 4. So that means that you are setting it equal to negative 4 and solving for x. The other thing to think about is first off, it says f of x, so that means you're going to use the f of x, right? So f of x equals 3x minus 7. F of x equals 4, so that means that we're going to replace f of x with negative 4, and you're going to solve for x. So you're just going to do the opposite, so plus 7 to get x by itself. So 3. All right, equals 3x. Divide both sides by 3. All right, and so x equals 1. Now, so you can circle that. That's your answer. And keep in mind what we just did. We found the x, 1 for the y, negative 4. So the point, 1, negative 4, is part of that function. We're just finding points based on if you're given x or y. If you're given the y, like in this one, you set it equal to that. If you're given the x, you plug it in. All right, now, last one. This is going to use two functions. It's saying that you're going to find the y for this point, and then you're going to find the y for this point, and then you're going to subtract them. So I'm going to set it up, as one long problem. You can, if you would like, do one and then the other. So what I mean is, so first off, h of 3. Let's do that one. H of x, there it is. I'm going to put brackets around this, and we're plugging in 3. So for h of 3, we're going to plug in 3. So 3 squared plus 2 times 3 minus 4. I just took this and I plugged in the 3 everywhere I saw an x. And let's go ahead and do that right now. Let's do one thing at a time here. Okay, so 9 plus 2 times 3 is 6. So do the multiplication first. And then this is a mistake I see a lot, guys. Once you get to addition and subtraction using order of operations, just do it in order. Don't do the addition, then the subtraction, or whatever. Just do 9 plus, do it in order from left to right. 9 plus 6 is 15. minus 4. I'm just keeping the brackets around it. So the answer here for this one is 11. That's just for the h of 3. All right, in green, I'm going to put our minus in between. And what we're going to do then is, in blue, we'll do k of 4. So k of x right here, we're going to replace, it's an absolute value, replace that x with 4. All right, so here we go. We got negative 12. That's supposed to be plus 5. All right, so negative 3 times 4 is 12. Do the multiplication first. Then negative 12 plus 5, absolute value of negative 7. Now the absolute value would make it positive, so 7. So we have, and so k of 4 is 7. H of 3 is 11, but it says h of 3 minus k of 4. So 11 minus 7 would be 4. And that is our answer. All right.